In this video, we're going to learn how to simplify a rational expression. A rational expression is an expression of the form p divided by q, where p and q are both polynomials and q is not 0. Here's an example. Suppose we have 2x squared minus x cubed minus x to the fourth divided by x to the fourth minus x cubed. To simplify this, we're going to need to factor p and q, our numerator and denominator, as completely as possible. Let's start by factoring p. First, I notice that I have a greatest common factor of x squared that I can bring out in front. That leaves me with 2 minus x squared in parentheses. Now I can rearrange the terms inside the parentheses. I'll write it as a trinomial in descending order from highest to lowest exponential value. So now I have x squared times negative x squared minus x plus 2. From here, I have a negative lead coefficient. I'm going to bring that negative sign out in front. So I'll have negative x squared times, and essentially by factoring out that negative sign, I'm changing the signs of everything inside the parentheses. So I have x squared plus x minus 2. Now I'll factor the trinomial. To do this, I can use the AC method if I want, where a times c is 1 times negative 2. I'm looking for factors of negative 2 that add up to 1, which is our coefficient of our middle term. Well, factors of negative 2 that will add up to 1 are 2 and negative 1. Since our lead coefficient is 1, I know that this trinomial in factored form is going to be x plus 2 times x minus 1. I still have my negative x squared that I need to write up front. So now the numerator, p, is completely factored. Let's factor our denominator, q. X to the fourth minus x cubed has a GCF, or greatest common factor, of x cubed. So I'll write x cubed out in front times x minus 1. So I'll take that, write it underneath my factored numerator. And now that the numerator and denominator are completely factored, I need to look at what restrictions I have in my domain of my function, or my rational expression. And I do that by setting each factor in the denominator equal to 0 and solving. I have the factor x cubed equals 0, which I can solve by taking the cube root of both sides. So x equals 0. Now I'm going to write x is not equal to 0 because this is a value that x can't be. And the reason why is that if I plug in a 0 for x in the denominator, I'll end up with a 0 denominator. And in math, we don't want a 0 denominator. A 0 denominator means the expression is undefined. We also look at our other factor, x minus 1. If we set that equal to 0 and solve for x, we get x equals 1. In our case, that means we say x cannot be equal to 1, since that would also result in the 0 denominator if we were to substitute it back into the denominator of this expression. So these are our domain restrictions, 0 and 1. Now we're ready to cancel like terms. I see here that I can cancel x squared, and I can cancel x squared out of my bottom term. X minus 1 and x minus 1 in the numerator and denominator are also common factors. And so this leaves me with negative x plus 2, keeping that in parentheses, divided by x. This is our simplified rational expression where x cannot be equal to 0 and x cannot be equal to 1. That's it for this example, and I hope you've enjoyed the video.